Quick, graph y equals natural log of the quantity x plus 1 plus 2 by hand, 2 different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. First, we need to decide what the parent function is and its shape. It's y equals natural log of x, and this is its shape here. Looks like an easy chair kind of dumping you out. Keep in mind it also has a vertical asymptote. And natural log and e to the x are inverse functions, meaning you interchange the x and y coordinates. We need to identify the parameters, and these are values in the expression that affect the graph. In this case, there are 2 of them. How do they affect the graph? Well, the plus 2 shifts all points up 2, and plus 1 inside the parentheses shifts all points left 1, including the vertical asymptote, which used to be at x equals 0 and now is at x equals -1. Also, our quote new origin will be at -1 because of the left 1, +2 because of the up 2, and so we'll plot that because all points will be plotted relative to this new origin. Now we're ready to do the natural log of x dance. Keep in mind again, natural log and e to the x are inverses, and here are the powers of e that we should just know. So right 1 up 0 is what we would normally do, and there's nothing to affect it. We've already taken care of the parameters. So right 1 up 0. Right e, which is about 2.7 up 1. Right e squared up 2, because the natural log of e squared is 2, and e squared is about 7.4, so over 7.4 up 2. Write e to the -1 down 1. Natural log e to the -1 is -1, and the reciprocal of e is 0.4. And write e to the -2 down 2. Natural log of e to the -2 is -2, which is the reciprocal of e squared. So 0.14 down 2 from that new origin. We can go ahead and connect the points using the asymptote as a boundary line. And this is our graph right here. Compare it to the parent function, and you can see that it's been shifted up 2 and shifted left 1. Second way, using a table. Again, these are the things we need to recall about being inverses and the powers of e. Here are 5 points on our natural log function. Again, the plus 1 shifts all points left 1, which means we have to subtract 1 from each x value. So 7.4 minus 1 is 6.4. 2.7 minus 1 is 1.7. And we're going to ask you to pause, finish the x values, and resume when you're ready. One minus 1 is 0. 0.4 minus 1 is -0.6. And 0.14 minus 1 is -0.86. The other parameter, plus 2, shifts all points up 2, which means we need to add 2 to each y value. So 2 plus 2 will be 4. And now we can go ahead and plot that point, 6.4, comma 4. We're going to ask you to pause, complete the 4 other y values, plot the points, and finish the graph. Press resume when you're ready. One plus 2 is 3, so we'll plot 1.7 comma 3. 0 plus 2 is 2, 0, 2. It's going to be our y-intercept. -1 plus 2 is +1, -0.6 up 1. And 2 and -2 make 0, so -0.860 will be our x-intercept. Again, we'll look at the drawing the asymptote, seeing how this is flattening out along the line x equals -1. That'll be our boundary line. Connect the points using that boundary line. and comparing it to the parent function. Now you try one. Graph y equals a natural log of the quantity x minus 3 minus 2. Use either method or both for the practice. Press pause to do this and resume when you're finished to check your answer. And here's your answer in green as the graph and also the table compared to the parent function.